In chapter 7, we're going to talk a lot about exponents. So before we move in about talking about properties of exponents and how to solve for exponents, you need to learn how to graph and how to explore and model exponents. So what we're going to talk about a lot today are just the equations. That's going to be the main focus today, are the equations. So your goal, it says, is to model it. The word model, okay, when you guys hear the word model, what they're talking about is number one, the graph, and the equation. Graphs and equations are how we model. You can represent a repeated multiplication, being an exponent, with a function y equals a b to the x power, where b is a positive number other than 1. So if we look at problem 1, we're going to start just with a simple graph, okay? But let's make sure that we can label a couple of things. What I want you to understand is that all of these could be rewritten with a 1 dot in front of them, all right? So I want you to say this is also y equals 1 dot 2 to the x. Now that's going to be beneficial for when we go further, okay? What you should know here is that 1 is a and 2 is b, okay? We'll talk about why that's important later on in the video, but I want you to understand that this could be rewritten so that 1 is a and b is 2. So we're going to make an xy chart. Now when you make an xy chart, we're going to pick our typical values, -2, -1, 0, 1, 2, but I like to go to 3 if possible on these. It'll give us a much better graph. So let's plug these things in. This is going to be 2 to the -2 power, which is 1 over 2 squared, which is 1 over 4. Just remember, negative exponents mean they need to go to the bottom. You should remember that from chapter 6. Now we have 2 to the -1 equals 1 over 2 equals 1/2. Now let's plug in 0. 2 to the 0th power simply equals 1. Let's plug in 1. 2 to the first power is 2. Let's plug in 2. 2 squared is 4. Let's plug in 3. 2 to the third is 8. Now let's plot our points. I like to do the biggest one first. I think it's easier. Over 3 up 8. Over 2 up 4. Over 1 up 2. Over 0 up 1. -1, 1/2. -2, 1/4. Now look at how these dots kind of align. They kind of look like a J, so why don't you put that over here? Looks like a J, right? So we're just going to connect it that way. Watch how I connect. It never crosses the x-axis. Write that down, please. Never crosses x-axis. At least not yet. I'll teach you someday and when it would. But right now we're going to say it never crosses the x-axis. It just approaches it, but it never touches it. What is the graph of these ones? Well, make our xy chart on all of them. Okay. Now remember, a could be rewritten as y equals 1 dot 4 to the x. Okay. B could be rewritten y equals 1 dot 1/3 to the x. And C is already rewritten. Okay? C already has the A. This time A is 2 and B is 3. This time A is 1, B is 1/3. And I will teach you why that's important a little bit later in the lesson. Letter A, 1 is A, 4 is B. And those are just important to label. We'll talk about those later in the lesson. Alright, let's start with -4. We'll plug in -2, -1, 0, 1, 2, 3. 4 to the -2 power is 1/16. Because it's 1 over 4 squared. 4 to the -1 power is 1 over 4. 4 to the 0 power is 1. Anything to the 1 power. 4 to the first power is 4. 4 squared is 16, getting big really fast here, and 4 to the third is 64. Note that 4 to the third is too big. We're not going to be able to graph this. 64 is too big. So let's plot everything else. Negative 2, 1/16 is super duper small. Negative 1, be just a tad bit bigger. 0, 1, 1, 4. Now 2/16, we're going to have to count real tall. 1, 2, 3, 4. It's going to be way up here somewhere at 16. So just eye it up. Now connect your J. You should notice that this one is more steep than the last one. And just like the last one, it's not going to cross the x-axis. Let's try the 1/3. So we're going to do negative 2, negative 1, 0, 1, 2. We could plug in 3, but I'll show you in a little bit why 3 will be a little useless to us. So 1/3 to the negative 2 power. Now I'm going to do this on the back because I just want to make sure you guys remember your exponent rules. If you have 1/3 to the negative 2 power, that's really 3 over 1 to the positive 2 power. And that's really just 3 squared, which is 9. Okay, now let's do negative 1 on the back. So we do 1/3 to the negative 1 is really 3 over 1 to the first, which is really 3. Okay, 1/3 to the 0 power is just 1. 1/3 to the first power is 1/3. 1/3 to the second power is 1 over 9. And 1/3 to the third power is really large. Well, it's actually really small. The denominator is big. It's 1 over 27. Let's plot our points. Negative 2, 9. Negative 1, 3. 0, 1. Did you notice 0, 1 has been a point in everything so far? 1, 1/3. 2, right there. Now look at this one. Should we make a little star here and say this J is backwards? Now tomorrow, I want to know, why do you think this J is facing backwards? What makes this problem different than the others? So tomorrow when you come in, I want you to tell me why this problem is different. Let's go to part C. All right, now part C, anybody who wants to know, you should know that part C is going to be double the height of the base of 3. So what we're going to do is we're going to plug in my normal numbers. Ready? So we'll do 2 times 3 to the negative 2. I'm going to do this one on the back. You ready? 2 times 3 to the negative 2. That's really 2 times 1 over 9 because of 3 squared, which is really 2/9. So ready? Right here. This ends up being 2 over 9. Let's do negative 1. So that's 2, 3 to the negative 1 power is really 2 times 1 over 3, which is really 2/3. I'm going to make a note here that says C back. Okay, that way whenever you go to study, you know where it was. And this one too, I'm going to make a note. I'm going to say C back. Okay? Alright, so let's plug in 0. Well, anything to the 0 power. Ready? Let's do this. 2 to the 3. 2 times 3 to the 0 power is really 2 times 1, which is really 2. Okay, there it is. Let's do 1 now. I think I can fit this on the front not going to be difficult, no more fractions. That's really just 2 times 3, which is 6. Let's plug in 2. That's 2 times 3 squared. Well, 3 squared, that's 2 times 3 squared. 3 squared is 9, times 2 is 18. I'll do 3, but I probably won't plot it because I think it's going to be way too big. So I do 3 cubed is 27, times 2, that's 54. This is way too big to graph. Okay, so let's plot our points. I'm going to plot the big ones first. Over 2 up 18. So it's going to be way up here somewhere. Okay? Now 1, 6. This one is a very tall graph because not only is it a base of 3, it's also being multiplied by 2. Okay, I'm going to say that again. This one is a very tall graph because it has a base of 3, but it's also being multiplied by 2. Write that down if you didn't quite understand it so we can talk about it. And then these are just getting really, really, really small over here. Make your J. Approach the x-axis, but do not cross it. Approach the x-axis, but do not cross it. Alright, I'm going to section this off for anybody who needs to study my notes by hand. Okay? Give me a moment. That goes there. That goes there, and then the rest. Okay. What generalizations can you make about the domain, range, and y-intercepts? Okay, let's talk about the y-intercepts. I like to talk about the y-intercepts first because I think they're easier. The y-intercepts, did anybody notice? They were simply the a values. Okay? Like on this one, a was 1, so our y-intercept was 1. On this one, a was 1, so our y-intercept was 1. On this one, a was 2, so our y-intercept was 2. Now the domains. The domains are like, what can you plug in? You can plug anything in, so therefore your domains are all reals. Or if you want a negative infinity to positive infinity, same difference. Your ranges. Your ranges are limited. They only have a positive infinity, okay? And they usually start around the x-axis. Okay? I'm going to put a star by that because they don't always start at the x-axis. They usually do. For everything that you'll look at today, I think they're going to. The next little paragraph we'll talk about, and then we'll do the rest on another video. This little paragraph talks about exponential growth and exponential decay. And here's the main thing. This line here is one that is decaying. Alright, let's say this. Let's say it starts decaying fast. I'm going to give you a real life example of this whenever you come to class tomorrow. It starts decaying fast, and then it slows down. Whereas if it's exponential growth, it grows, I guess it kind of grows slowly at first, but then it grows really, really fast. Okay? That's really the difference. Notice that for everything we're going to look at today, the x-axis is your asymptote. What that means, an asymptote is simply a line it will never cross. Okay? And that's why I kept saying get close to it, but don't touch it. I'm going to talk about the rest in the next video.